scalar quantities, and vector quantities. Let's explore what these terms mean and how they differ from each other. Let's start by understanding what scalar quantities are. A scalar quantity is a physical quantity that has only magnitude but no direction. Some common examples of scalar quantities include mass, temperature, speed, time. Energy, for instance, when we say an object has a mass of 5 kilograms, we're only concerned with the amount or magnitude of the mass. It doesn't make sense to say the mass is pointing in a particular direction. Similarly, when we say the temperature is 37 degrees Celsius, we're only specifying how hot or cold something is, not the direction of that temperature. Speed is another example of a scalar quantity. When we say a car is moving at 60 kilometers per hour, we're only talking about how fast the car is moving, not the direction in which it's moving. Now, let's move on to vector quantities. A vector quantity is a physical quantity that has both magnitude and direction. Some common examples of vector quantities include displacement, velocity, force, acceleration, momentum. For instance, when we say an object has been displaced by 5 meters to the east, we're specifying both how far the object moved, that's the magnitude, and in which direction it moved, east. Velocity is another example of a vector quantity. When we say a car is moving at 60 kilometers per hour toward the north, we're specifying both how fast the car is moving and the direction in which it's moving. Force is also a vector quantity. When we apply a force of 10 newtons downward on an object, we're specifying both the strength of the force and its direction. Now, let's directly compare scalar and vector quantities to better understand their differences. The fundamental difference between scalar and vector quantities is scalar quantities have only magnitude. Vector quantities have both magnitude and direction. Let's visualize this with a couple of examples. Speed versus velocity. Speed, 60 kilometers per hour, scalar, only magnitude. Velocity, 60 kilometers per hour north, vector, magnitude and direction. Distance versus displacement. Distance, 5 kilometers, scalar, only magnitude. Displacement, 5 kilometers east, vector, magnitude, and direction. Let's see how these concepts apply in real-world contexts. When giving directions to someone, you need to specify both distance and direction. For example, walk 100 meters north, then turn right and walk another 50 meters. Here, each instruction is a vector because it includes both magnitude and direction. In navigation systems like GPS, vectors are essential for providing accurate directions. The system calculates the displacement vectors needed to get from your current location to your destination. In weather forecasting, both scalar and vector quantities are used. Temperature is a scalar quantity, while wind is described as a vector because it has both speed and direction, like 20 kilometers per hour from the southwest. In physics problems, distinguishing between scalar and vector quantities is crucial for solving problems correctly. For example, when analyzing forces acting on an object, we need to consider both the magnitude of each force and its direction to determine the net effect. To summarize what we've learned today, scalar quantities have only magnitude. Examples include mass, temperature, speed, time, and energy. Vector quantities have both magnitude and direction. Examples include displacement, velocity, force, acceleration, and momentum. The key takeaway is that whenever direction matters in describing a physical quantity, we need to use vectors, not scalars. Understanding the distinction between scalar and vector quantities is fundamental to physics and many other fields of science and engineering. Thank you for watching. I hope this helped clarify the difference between scalar and vector quantities.